In this video, we'll explore the meanings of rate, ratio, and proportion. Now, when we talk about ratio, we're looking at a relationship between two quantities. And when we say the ratio of A to B, what we're meaning is that for every A units of that quantity in the first order, we're going to have B units of the second quantity. For example, if I said for every 5 apple slices, we add 2 bunches of grapes, it's a ratio of 5 to 2. So if I put out 5 apple slices, I expect 2 bunches of grapes. If I put out another 5 apple slices, I would expect still 2 more grapes to be paired with it. Now if I look at that notation, I could write 5 to 2, literally the word TO. I could put 5 colon 2, or I could write it as a fraction, 5 halves. Now when I talk about rate, I'm looking at two quantities that are being measured in different units. One common example is speed. When I measure speed, I'm looking at miles per hour. So if I run 9 miles per hour, that means I'm running 9 miles for every hour. That's a 9-to-1 ratio. Okay, if I look at birth rates in the United States, represents a total births per 1,000 people in a year. So when I see a birth rate of 32, what I'm really seeing is that it's 32 births for every 1,000 people. Now when we talk about proportions, what we're actually looking at are equivalent ratios that we can then state, and they're often going to just have, it's going to be some form of the other one just multiplied by the same number. So if I had 12 colon 5, that's equivalent to 36 colon 15, because 12 times 3 is 36 and 5 times 3 is 15. Again, the key part there is they're both being multiplied by 3. So we again know that a proportion is going to be an actual statement with the equal sign in between there. So we would write that as 12 colon 5 equals 36 colon 15, or you'd also see it as 12 fifths equals 36 fifteenths. Now I can use a table to help me with trying to create equivalent fractions and equivalent ratios. So if I had here, I'm making cookies and I need 4 tablespoons of butter for every 9 tablespoons of milk. Well, if I look at each of these parts, to make one batch means I need a 4-to-9 ratio. If I want to make 2 batches, I'm going to double both of those numbers, so it becomes an 8-to-18 ratio. 3 batches, I would triple each number. If I needed just a fourth of a batch, that sometimes happens when I'm baking, I don't need as much, I'd multiply both values by 1/4. If I needed a half batch, I'd multiply each of them by 1/2. So when I'm trying to create my equivalent ratios, just like equivalent fractions, I need to multiply both portions of the ratio by the exact same number. Now I can also graph my ratios as well to do a comparison. For example, if I say it takes me 3 seconds to walk 2 feet, I can let my x value be the number of seconds and my y value be the feet walked, because it's a 3-to-2 ratio. So if I start to plot out some points, I'd have 3-to-2, 6-to-4, 9-to-6, 12-to-8, and I can plot that out. There's 3-to-2, 6-to-4, 9-to-6, 12-to-8, and each of those are coordinate pairs, x comma y. And what I can do then is I can actually draw the line through there and say that any other point that follows this same ratio will fall on this line. And that can also give me some of my fractional ratios that are possible as well.